guys, welcome again. After so long I have come to my channel. So in this session I am going to discuss about function and its types. And in the previous sessions on relation has been completed. So I have come to the topic function. So let's get proceed. So function is a type of relation. So function is nothing but a kind of relation. So the first definition is a function f from set A to set B. A function f from a set A to a set B is denoted by f from A to B and is defined by, the function is defined as ordered pair xy such that x belongs to A and the second element belongs to the second set B, such that there are some conditions such that each element of x of A corresponds to a unique element of y of B under the function f, and we say y equal to fx. Now the function is nothing but a relation, and this goes from a set A to another set B, that is f from A to B, and it is defined as f equal to ordered pair xy, where this element belongs to the first set and this element belongs to the second set, such that each element of x of A, the elements of x are related to the elements of B under the function f. And so in the function f we say y equal f of x. We write y as f of x, and this is called the image of x. Y equal to fx or y is called the image of x, and as a consequence x will be called the pre-image of y. As a consequence, x will be called pre-image of y. And this is the definition of function. So in the function f from A to B, the set A is called domain. The set A is called domain of the function f, and the set B is called codomain of f. Now what is range here? The set of elements of B which are images of these elements of A is called range of the set A. So here the set of elements of B, the elements which are in the set B, which will be the images of the elements of the first set, is called range of A, and range is denoted by function f of capital A. Now I am going to show some figures so that you can understand what is function actually. So let's get started. Here you can see the first figure, number 1. The set A is related to the set B. Now in the set A we have 3 elements, 1, 2 and 3, and in the set B we have 3, those are A, B and C. Now we see that 1 is related to A, 2 is related to B, and 3 is related to C. According to definition of function, we have each and every element of A corresponds to a distinct element of B. So here 1 is related to a single element A, 2 is related to B, and 3 is related to C. And there is no other element left, in the set A. So this represents a function because each and every element of A relates to distinct element of B. So this is a function. Now come to the figure 2. Here also the set A contains 1, 2 and 3, and B contains A, B, C. We see 1 is related to A and 2 is related to two different elements of B, which are B and C. 2 goes to B and 2 goes to C also, and 3 is remain unrelated. So according to definition of a function, each and every element of set A should have corresponding distinct elements in the set B. So here this figure does not satisfy the condition of function. So this is not a function. This is not a function. Now here 3. So 1 is related to A, 2 is related to C, and 3 has no corresponding elements in the set B. Now, according to definition of function, each and every element of the first set should have distinct elements in the set B, or we may say should have distinct images in B. But there is no any image of 3, so this is also not a function. Now come to this. Here 1 is related to A and 2 is related to C and 3 goes to A. Now there is no element left unrelated, but the elements 1 and 3 have same images, that is A. This also satisfies the definition of function. So this is also a function. So here we have number 1 is a function, number 4 is a function, but number 2 and number 3 will not be function. Now if a function goes from R to R, if a function goes from R to R, that means the domain is the set of real numbers and codomain or range is also the set of real numbers, then this relation will be called real function. This function will be called real function. So I hope you understood. Now functions are of many types. The types of functions are, number 1 is one or injective. There is a function called one or injective. The definition is a function f from A to B is said to be 1 if the images of distinct elements of A are distinct elements of B. The definition says a function f from A to B is said to be 1 if the images of distinct elements of A, if distinct elements of A have distinct images in B, then it will be called 1 or injective function. Here the example, the identity function f from the set of real numbers to set of real numbers defined by f of x equal to x for all x belongs to the set of real numbers is 1 function. So the identity function fx equal to x for all x belongs to R is an example of 1 function. Now the type 2, many one. A function f from A to B is said to be many one. A function f from A to B is said to be many one if at least one element of B is the image of more than one element of A. Already we have seen a figure where one element of B is the image of two elements of A. So I will show at the end of this video. I will explain in a better way. Here the example of many one function. The modulus function f from R to R defined by f of x equal to mod of x for all x belongs to R is many one. So the modulus function is many one function. Now type 3, onto or surjective. There is another function called onto or surjective function. A function f from A to B is said to be onto if every element of B is image of some element of A. That means the elements of A should have images in B, or we can say in other words, the elements, each and every elements of B should be images of some element of A. Then this function will be called onto function. So the example will be the identity function f from R to R defined by f of x equal x for all x belongs to R. This is an example of identity function, and it will be onto or surjective. The identity function f from R to R defined by f of x equal x for all x belongs to R, and this is an example of onto or surjective function. So I will help you understood by showing some figures related to these types. So let's proceed. So there are total 5 types of functions, but I have mentioned only 3. In the next class, the next will be discussed. So let's understand the type 1, 2 and 3 with some figures. In type 1, that is 1 or injective, the example was the identity function f from R to R, the identity map defined by f of x equal x for all x belongs to R, is an example of 1 or injective function. So here I have taken some elements from the set of real numbers. I have showed only some elements: -2, -1, 0, 0.5, 1, and here the other elements goes, and also there are also other elements. Now by the definition of this function fx equal to x, for all x belongs to the set of real numbers, fx equal to x, that means the element of the first set have images itself. So the element -2 is related to -2, -1 is related to -1, 0 is related to 0, 0.5 is related to 0.5, and similarly 1 is related to 1, and so on. So the elements of the first set R have distinct images in the second set R. Therefore, the identity function f from R to R, fx equal to x for each and every element belongs to R, will be an example of 1 or injective function. Number 2 was many one function, and the example was the modulus function fx equal to mod of x for all x belongs to R. So the modulus function will be an example of many one function. How? Now we have taken 3 elements only here, -1, 0 and 1. No doubt these elements belongs to the set of real numbers, and these are also belongs to the set of real numbers. Now since f of x equal to mod of x, that means for any element of x we have the positive value only. Now for the element -1 we will have f of -1 equal to mod of -1, and mod of -1 is nothing but +1, so -1 goes to +1. Now f of 0 will be mod of 0, and mod of 0 is 0, all we know, so 0 goes to 0. Similarly, f of 1 is obviously related to 1. Now we have seen the element 1 in the set B have two pre-images in set A. Those are -1 and +1. So according to definition, this function is an example of many one function because the element 1 is the image of two elements in the set A. Therefore, this is an example of many one function. Type 3, that was onto or surjective function. The example was the function f from R to R and defined by f of x equal to x for all x belongs to R. It is an example of onto or surjective mapping. Now the set R here, I have taken the elements minus 1, 0, 1, 1.5 and here also minus 1, 0, 1, 1.5. The definition is f of x equal to x. So minus 1 related to minus 1, 0 goes to 0, 1 goes to 1 and so on. Now according to definition of onto or surjective mapping, every element of B is image of some element of A. Here we see these are the elements of the set B or the second set. These elements are the image of some elements in this set, right? So according to the definition of onto or surjective mapping, the identity map f from R to R and f of x equal to x for all x belongs to R, it is an example of onto or surjective mapping. Here these are the types, 1 or injective, many one, and third one is onto or surjective. The next types, injective function and bijective function, I will be discussing in the next class. So here is all about the function and its types up to number 3. The first one is 1 or injective, second one is many one, and third one is onto or surjective. So here this is the video. I hope you are enjoying the class. That's all. So please like the video, share and also subscribe to my channel. Keep calm and love maths. Thank you for watching the video. Bye bye.